Okay, right triangle word problems. Big part of the test are word problems. A whole section. Thank you. A whole section of word problems on the test. Just a heads up, make sure you are ready for them. All right, number 1. From a point 50 feet in front of a building, comma. Before I go any further, I'm going to tell you right now there's one just like this in your homework. So when you get to that homework problem and you're stuck, look at your notes. From a point 50 feet in front of a building, the angles of elevation to the base of a sign and the top of the sign are 45 degrees. And this picture will be given to you in the textbooks. I will draw it for you in just a second. And 47.75 degrees. Period. Find the height of the sign. All right. Let's draw our picture. Again, the picture for this one will be given to you. So here's our building. In the top of our building we have this sign, this banner, or whatever it may be, with information labeled at the top of the building. I think in the textbook it's a flag. Okay, from a point 50 feet in front of the building, so we're going to call this the front, and here's 50 feet away. So from this point here, 50 feet from the base of the building, the angles of elevation to the base of the sign and the top of the sign. They gave you 2 of them. So to the base of the sign and to the top of the sign. Do you see the 2 triangles we're drawing now? Yes? Okay. So 2 different angles of elevation. First angle of elevation is what? 45. That's this one here, 45 degrees. And that's to the base of the sign. What's the second angle of elevation? What is it? And that's to the what? Top of the sign. Does it make sense that this one here, the one in red, is the bigger value, the 47.75? Yes? Okay. I'm going to put an arrow here, 47.75 degrees. Find the height of the sign. So what we are looking for is this piece here. All right. First off, this little purple line that I made, do you agree if I cover this down here, I do have a triangle there that makes that side there X? Do you agree with that? Is that a right triangle, this little one right in here? It is not. So can I use SOHCAHTOA and all that stuff on that triangle? No, and it's called right triangle word problem. So I'm going to try to use right triangles. So here, can you tell me how many right triangles you see there? Can you see the one big one?
Yeah.
Yes. Is there another smaller one inside of it? You see the smaller one. The smaller one that has this here as just the height of the building, and the bigger one which has the height of the building with the height of the sign. I'm going to repeat that. The smaller one has this here, which is the height of the building, and then the bigger one that has this height here, which is the height of the building and the height of the sign. Any thoughts on how we can use those two right triangles to find just the height of the sign?
Can we find the height of the smaller triangle and then subtract it?
Okay, he said, can we find this height here and then subtract it from the big one? Good job, that is correct. So we're going to find the big height, the smaller height, and do what with the two? Subtract, and will it give us the height of the sign? All right, good job. So let's write that down. He said, can we do the height of the big triangle and subtract the height of the small triangle? All right, so I'm going to redraw the big triangle here just to have it. Okay, in the big triangle, we'll call this, I'm going to call this Y, since I already called that X. I don't want to, actually, I'm going to delete that or erase it. And we'll put a letter in there later. But I'm going to call the big one Y. All right, this is Y. What else do I have? What is this base length right here? 50, because it's this base length here. I didn't draw it exactly the same, but it is 50, bless you. And what is this angle right in here? Is that the 45 or the 47.5 if I'm dealing with the big triangle? 47.75. Okay, do we have enough to find Y? What tool are we going to use from yesterday? The tools that we had. Which one are we going to use? Which one? I hear someone whispering it. SOHCAHTOA. I heard someone say tangent. Okay, so we put our pencil marking here. If you wanted to use this top angle, could you? Yes, you'd have to find it. I'm not going to. So since I have that one marked, what is Y in reference to the 45.75 degrees? Opposite. And what is the 50? Okay, and you guys are telling me that is tangent. Tangent of 47.75 equals what over what? Y over 50. I'm going to let you guys do that now. Plug it into your calculators and get a decimal value. 3 decimal places. I should see a calculator on everyone's desk. If you did not bring your own, you were supposed to come up and grab one already. Some people grabbed them in the beginning, some people grabbed for others. If you do not have one, please come up and get one. So this is the one where you multiply both sides by 50. And this here on the left side is what you plug in your calculator. So go ahead and plug that in. What do you get? Starts with the 5. 55.046. Okay, 55.046. And this is all in feet. Okay, and then minus the height of the smaller triangle. So here's my smaller triangle. And since I had that X, and some of you may have put it, I'll put it back and leave it as X. If I'm calling that X, can I call this side here X? No, you cannot. If this is Y, and I've already called that X, what would I call this side? Any other letter would be H. H for height. Z. W. Okay. Is this still 50?
Yeah.
And what is this angle in here if it's the smaller triangle? 45. And do we do it the same way? Opposite over adjacent? If I'm still doing opposite over adjacent, and adjacent is still 50, and opposite is unknown just like it was here, how is my answer going to come out different? Because it's a different angle, right? This is 47.75 and this is 45. Which I'm wondering if any of you guys remember without your calculator what tan of 45 is. 1. So can anybody do that without their calculator? What is it? 50. Plug in your calculator and see if it works. 50 times tan of 45. People are saying it should come out to be 50. Does it work?
Yeah.
Yep. All right. 50 feet. And what are we going to do with these two numbers? Subtract them. Because you're doing the big height minus the smaller height will give you the purple height, which is what we're looking for. And has anybody done that already? What does that give you? 5.046 feet. Questions? Make sense? Okay, number 2. Oh, before I actually do number 2, I want to go over bearings. A bearing. Have any of you guys dealt with bearings before in Math 3? No? Okay. They're angles made with north and south lines. So you'll see something like this. North, 30 degrees east. Yes or no? Have you seen that before in Math 3? No? Have you heard it before? And if you watched any kind of like movies where there's like people at sea, at the ocean, what's that one with Tom Hanks? What is it? He's the captain. Is it called Captain? Yes. What is it called? Well, that one. I've heard it. He does use the bearings. Something like north, 30 degrees east. Okay, why do they use bearings? When you're out at the ocean and you're giving directions, can you say, make a right at Shaw, go down for 2 miles, make a left on First Street and Blackstone? No, you can't, right? You can't do it in the ocean. There's no like roads to say, go here, make a right, make a left. So they use bearings to get their directions of where they're supposed to head or where they're supposed to go. They position their boat north, and then they shift it 30 degrees east, and then they take off. And if they're off even just a degree or 2, will it take them to a different place? Yes. So is it important for these angles to be accurate?
Yeah.
Yes. If you say, 30 or 31, and you're going off a far distance, and you go 31 instead of 30 in the far distance, is it going to make a difference? Yeah, you'll end up in the wrong spot. So again, these mathematics that they calculate, they need to be exact. All right, so how do you graph north, 30 degrees east? All right, first off, which one's which? Top here is north, bottom is south, left here is west, and this is east. Yes, I will. Okay, north, south, west, east. Never eat soggy waffles, whatever your teachers taught you. I don't know, like News, there's different. N-E-W-S. Okay, we're ready? So north, 30 degrees east. So I'm going to draw my coordinates like this again. And this one is always your starting. Your first one, now it says north and south lines because this first one here will always be north or south. Your second one will always be west or east. So I'm going to erase this. Well, actually, no, I'll leave it. You'll always start with your line pointing north or south, and then from there you're going to position yourself. Okay, so north, I'm going to position, like imagine facing north. You're positioning yourself, is what I was trying to say. You're positioning yourself facing north, yes?
Yeah.
And then you're going to turn yourself 30 degrees east. Will you be going to the right or to the left? To the right, how many degrees? 30 degrees. So approximate 30 degrees and then draw a line. That there is north 30 degrees east. All right, so again, you're always going to be positioning yourself north or south, and from there swinging right or left. Got it? Okay, so another one, let's try south 47 degrees west. So I'm going to put a dot here. Am I going to draw my arrow going up or going down? Down, because it is south. And then I'm going to swing from this dot. Imagine your dot here, and this line here is swinging right or left. Which way is it going to swing if it's 47 degrees west? It's going to swing to the left. How many degrees? 47. So that there is south 47 degrees west. Oh, I put 45. All right, questions? Okay, let's try one more. I'm going to give you, I want you to try it. North 17 degrees west. North 17 degrees west. All right, I'm going to put my dot. Am I going to draw my arrow going up or down? Up, because it's north. And from this dot, imagining this line swinging right or left, which way is it going to swing?
Left.
Left, because it's west. And how many degrees? I know that's much bigger than 17, but I just want to at least be able to write it in there. All right? Makes sense? All right, we're going to start number 2. A boat, nope, boat A, that's what I wanted to write. Boat A leaves dock going north boat B leaves dock going north 37 degrees east at 27 miles per hour. Period. After 3 hours, boat A is exactly due west of boat B. How far apart are they? All right, I'm going to mark this point here as port, only because they're heading north, so I want some room up there. So this is the port they're leaving from, and boat A leaves in its dock, is what it said instead of the port. Boat A leaves the dock, the docking station, going which direction? North. It's going that direction. Do you agree? I don't know how far, so I'm going to leave it there for now. And boat B leaves the same dock going north 37 degrees east. All right, so does this boat take off in the same direction as the second boat? Does it take off the same direction as the first? No, because the first one went straight north, and the other one's going, which one? North 37 degrees east. All right, so which way do I put my first arrow if it's north? Going up or going down? Up. So this is north. And which way do I swing? Right, because it's east, 37 degrees east, and then the boat goes off in that direction. So do you agree that little angle there will be 37 degrees? Yes? After 3 hours, boat A is exactly due west of boat B. So if I stopped right here, is that exactly due west, that line right there? No, do you agree it would be a horizontal line like this? Yes, so I'm going to continue that. All right, so if it's exactly due west, it's horizontal. So here's boat A, and here's boat B, and do you agree there's a right angle in there? Hello, Mrs. Torres? Yes. Okay, I'll let him know. Bye-bye. Leonard, you know what today's assignments are, right? There's 2 of them?
Yeah.
Okay. All right. Any questions on the drawing? Okay. Where do I put the 27? Do I put that anywhere in the picture? Where, say it again? On the side of boat B? Okay, will I use the 27 as an actual number in my picture?
No.
No. Okay, what did you say, Madison? Okay, what's the formula? Distance equals rate times time. Do you guys remember that?
Yeah.
Distance equals rate times time. Is this a rate here that I've given you, 27 miles per hour? It's a rate. If it is a rate, you will not be putting the rate in your picture because these are distances traveled. Do you see that? All right. So distance equals, and you said what, Madison? 27 times what? 3. Why, did you say 3? Yeah. Why 3? Good job. She said it's miles per hour and it's 3 hours, so the rate is 27 and the number of hours is 3. So calculate that really quick. What do you get? 81. And where does that 81 go? We'll call this height, base, and hypotenuse. Where would it go? Vertical line, horizontal line, or hypotenuse. It's the, this is boat B leaves dock, and boat B is the one traveling 27 miles per hour. Hypotenuse, 81 miles. All right, do you guys agree with that? How far apart are they? Where do I put the X? This vertical line is the X or the horizontal line? This is the X. Okay, do I have enough information to find the X? All right, where do I put my pencil marking at?
37.
The 37. In reference to the 37, what is the X? Opposite, what is the 81? Hypotenuse. And what is opposite over hypotenuse? Which function? Sine. Sine of 37 equals X over 81. Go ahead and multiply and plug in. And then check with the people sitting around you. All right. Make sense? What did you guys get as your answer? X equals 48.7 what? 47 miles. All right, are we good? Okay, we're going to try one more. This next one I'm going to give you, I'm going to have you try it on your own. and then I'm going to give you time to work. Questions on number 2? Okay, number 3. A ship is 70 miles west and 50 miles south of port. What bearing should it take to get to port? What bearing should it take to get to port? All right, so the boat has taken off, and it knows it has traveled 70 miles west and 50 miles south of the port, and it wants to get back. And do you agree the shortest distance is going straight shot back instead of going up and over? Do you see that? Let's draw the picture. All right, actually I'm going to have you guys draw the picture first, and then we'll talk about how to draw it. So do it. Draw your port, wherever your port may be, and draw the ship off at sea somewhere, not at the port. How would you draw it? Okay, did you guys draw it? I'm going to draw one, and you tell me if any of you drew it this way. I'm going to put port. This is my port. This is 70 miles west, and this is the 50 miles south. And then if this is the ship, and the ship wants to get back to port, do you agree the quickest, shortest distance is going straight down the hypotenuse? Yes? Did anybody draw it this way? Did anybody draw it the other way, going 50 miles down and then 70 miles over? Did anybody draw it that way? No? Did you? Okay. I want to talk about both ways. Both ways are going to work. One way will require one extra step at the end, but I just want to make sure you understand the difference. Okay, the question is, how far or what bearings does a boat need to take to get back to port? If this is the ship, bearings start with what? North and south, or west and east? So this boat would position himself in which direction first? North. So we know we're going to have north, blank. And then which way is he going to turn himself? Right or left if he's trying to get back to port? Right. And so if I'm going to the right, is that west or east? So do you agree our answer is going to look something like this? North, whatever this unknown angle is, and then the east. Yes or no? Yes. Okay. So if you've got it, you can continue. I'm going to explain this one really quick. If you solve this one and you find this unknown angle here, is that going to be the correct bearing you're going to need? It's not, because which way is the boat going to position himself first? If the boat is here and he wants to get back to port, he's going to position himself north, same thing. And is he going to move himself west or east? This angle answer that you found in here? No. Do you see that? So those of you doing it this way, what would you have to do after you find your angle in here? What would you have to do? Subtract it from 90 to find this angle out here, and that would be the one going in. If you're like, well, I didn't draw it that way, it doesn't matter, then you're fine. If you did, or if you ever do, you need to make sure that you recognize bearing start with north. And this graph here finds an angle inside, not, this is the angle outside that I need. North, how far? East, which is not the angle we're finding in this particular picture. Does that make sense? Okay, are you guys okay if I use this one up here, or do you want me to use the one down here? First one? All right, again, if you want to use this one, go for it. You're just going to subtract from 90 at the end. That's the only extra step, which really isn't all that hard. You just need to know how to do it. All right, so we're here. What do you want to call this unknown angle? X, Y, theta, Z, X? I heard X. All right, so if I'm looking for this, do you guys agree this is the angle I'm looking for to go right in that blank? North, so many degrees east, and then I drive back to port. All right, if this is the angle I'm looking for, if that's the angle I'm looking for, I'm going to put my dot there. In reference to that angle, what is 70? What is the 50? Which one is opposite over adjacent? Tangent of 50, tangent of 70, or tangent of x? Tangent of an angle, always an angle, equals what over what? 70 over 50. Now, who remembers what you do here when the angle is, that's the inverse. If you're looking for an angle, you type it in like this. Inverse tan of 70 divided by 50. You have an inverse key, that's the shift key in your calculator. Shift, tangent, and you actually see the little -1 symbol. And what are we dividing? 70 divided by 50. And what do we get? 54.462. Now, if you write this, and this is it, and this is how you give me your answer, is that okay? No, because it asks for a bearing, and this is what we need over here. I'm just going to rewrite it. North, blank, and what's the blank? 54.462 degrees east. Does that make sense? But if you're out at sea and you're trying to get back and you know you've gone 70 west and 50 south, you position yourself north, and then you turn yourself 54.462 degrees east and head off in a straight line, you'd end up back at port, back where you started. Did anybody do this one? Madison, did you do this one down here?
Yeah.
Did you get the same answer once you subtracted? Or are you doing it now? Okay. Can you tell me what you did on this side over here? Tangent of x equals. Did you flip-flop the 50 and 70?
Yeah.
Okay, does that make sense? And then after that, after you do the inverse, you would subtract it from 90, and you should end up with the same answer that we have here. Okay? Questions?